cut off of an old salvage shaft right here. It measures 7 7/8 diameter. And what I'm going to be doing is using this piece and making a part for my friend Andrew Alexander, Blacksmith Tools. He called me up and asked if I could make a part for him that he needs for one of his power hammers that he's been working on. He gave me some rough dimensions right there. This is not any kind of like real critical part at all. So he wants the OD to be 5 1/4 to match what was there. 2 3/4 inches stick right here. You got on one side there's a tapered machined on there. It sticks out 1 1/4 inches. Nothing critical with that. He says it's really just sort of like a lineup pin there. And then on the other side we've got 1.5 inch hole that's drilled in there, 1 1/4 inches deep. But we'll bore that, make it a nice clean bore. So nothing really precision about any of this, but we'll hit all of our dimensions. I cut this piece a little bit long just so that I could use this area here to go ahead and chuck it in the forge jaw, get it indicated, and we can do all of our OD machining here, machine our taper, and then once we're through, we can flip it around in the chuck and just face all this off right there. So we've got enough diameter here that this, once we turn it down and clear this keyway up, there'll still be plenty of diameter to finish out our 5 1/4 OD. So we'll go down to the Monarch Lathe and start making some chips out of this big hunk of steel. Okay, we're going to be using our forge jaw chuck, get this thing indicated in. Even though I've shown indicating many times over the life of my channel, every time I show it, I always enjoy seeing those comments from people that say that they actually enjoy watching me do this every time. There's always people that's constantly watching and trying to learn something because they haven't done things like this for themselves and they're trying to figure it out. So showing some indicating is just part of what it is that I do on my channel, and I enjoy doing it. But I got an extra trick here to show you guys that you can use for something like this. This is just an example. Now we have an open area right here behind the keyway that we can stick this indicator on just like this and get an OD reading right here, okay? So yeah, we're a pretty good ways off right there. But what if that wasn't there? What if that slot goes all the way through there and you want to indicate it? Now, of course, you can stick your indicator out here to where you barely have any preload on it like that, you know, and jump over that slot just like that. But here's another trick that I learned that you can do, and it works really well. So just take a rule, you know, 12, 18-inch rule. This is an 18-inch. And stick it down here right up against the V-way. Let me show you. I just stick it right up against the edge of the front V-way right there, all right? Now, bring your indicator around here like you always would and put some preload on it to push against this scale. About like that. I'm going to preload it about halfway. And that's going to push against the rule right there. I'm just making sure that it's square down at the bottom. Now you can roll right across that slot. And what you're doing is you're just reading the face of the indicator, but the indicator is moving against the surface of this part right there. So it's just like it being on the surface there. So you can use that to your advantage. So that's our low. We're going to go ahead and start getting this thing pushed over there because I was off quite a bit. Now this is the high. Loosen that one and snug that one. And loosen your lows, tighten your highs when you're on the OD. Now that's the low, that's the high. Kind of moves in between them after you get in there and start indicating it around. But you see how nice that works. This works really good if you've got, say you got a shaft that you need to indicate like this that's threaded. That works great for threads. You can measure, you know, just the OD of the threads anyway. If that, usually that'll work. You can just measure the OD of threads. In any kind of groove or slot like this that you got to jump over with the indicator. It's a great trick, and I'm glad I learned it because it's proved useful in many jobs that I've done. You see, so we're only 0.02 off right there. I mean, it doesn't have to be any closer than that. My main thing, see, that jaw is a little bit loose, so I want to make sure that all my jaws are tight at this point, that you don't have anything loosened up, because you're going to be taking some heavy cuts on this with an interruption. You don't want it to try to move on you and snatch it out of there and break a tool while you're trying to turn it. So everything's good and tight right there. So excellent little trick with the scale against the OD of the shaft to true up. And also keep in mind, it's helpful too, whenever you have a slot like this, keep this in between your jaws so that you can get a direct reading right in line with the jaws there, okay? Let's test the waters using this L&MX insert tool here. I've got it set at 200 thousandths, so it's 100 thousandths step to cut, 200 thousandths total metal removal. All right, that looked like that worked out pretty good. Still got a little ways to go to get that keyway cleaned up, but tool handled it. I think it's going to work out pretty well. So we'll keep, because of that heavy interruption like that, that's why one reason I've got the feed rate down. We're running actually a 12 thousandths feed rate, so not as aggressive as I normally would with that tool, but because of the interruption, I'm trying not to shatter this insert. So I think we'll go back with a 200 thousandths cut on this right here. I set up my Noga Cool here. We'll use this to spray some coolant there on the insert. This works really well. I've got it adjusted right there for the tip of the carbide, and I'm going to use this instead of flood coolant there. It's a little bit less messy, and it's just going to help keep that carbide from getting hot. You just have to fine tune it on how much you want spraying out of it like that. Try another 200 thousandths, same cut we just did. Trick is just keeping the nozzle adjusted right where it needs to be. Almost cleaned it up. It will in that next pass. So we still have quite a bit to come down. We're gonna go into 300 thousandths on this pass, kicked it up to a 15 thousandths feed rate. So the depth of the tool is at 150 thousandths. Looks like it's doing good. The cut we just finished, I had it set at 400 thousandths depth of cut. So 200 thousandths depth on the tool bit. And I've got the feed box set at 17 thousandths per revolution. It's pulling off of a good chip, and because of that surface speed, the amount of metal that's coming off on this diameter, I can really tell that the Monarch is working on this. So I don't want to push it anymore. That seems to be a really good rate. We've got just about an inch to come off that. So we'll make a couple more passes with that tool, with that feed rate and depth there. So this is our last roughing pass we're gonna make to get down to our 5 1/4 OD. That'll leave me 30 thousandths just to finish it out. And I kicked the feed rate up to 21 thousandths per rev. Now that we've kind of reduced some of that metal on the diameter, it's handling a little bit easier now. That's a good coarse feed rate to really move some metal and get a shaft turned down quickly. So we got this area right up in here that we got to take way on down to less than an inch for our little tapered stub in. So I've got it set to 500 thousandths on the dial now, so 1/4 inch per side, and we're still running at 21 thousandths feed rate. So we should be able to pick it up and start moving a little bit faster right here. I've got it sped up to 319 RPM. We were previously running 264 RPM, trying to maintain right around that 500 surface feet per minute. See how it does on the 1/2 inch cut here. All right, you see that? We just stalled it. And I'm gonna have to drop back down to that lower gear range. We're in the high range there, and you can tell that it just can't handle it there. So I don't like doing that because you're liable to break something on the lathe here. Okay, dropped it back down in that 264, a little bit lower gear range, and I did drop the feed rate down to 17 thousandths. Let's see if it can handle that chip load there. Okay, so that's looking good. That's a pretty chip. I've got this end of the part completed now. We've got our taper there. That worked out real good. I just set the compound on, eyeballed it at 3.5 degrees. This isn't a critical thing right there. He just gave me the dimensions of the small diameter, the large diameter, and the length of it, and I calculated it at just over 3.5 degrees. So that worked out good. This is exactly on 5 1/4. So what we'll do is we'll flip it around. I'm going to use some soft jaw pads, some copper pads in between the jaw and this, and then we're just going to set up and start facing the rest of this material off right there. Once we get this faced, I just got to put a hole in there and then bore it to size, and then after that it'd be done. We've got our 4 jaw set to approximately 5 1/4. I'm going to be using these brass shims in between the jaw and the part to keep from digging into it. And I want to make sure that I got all the chips off the face here, because what I want to do is just bump it up to the face. Make sure there's no little fine chips in there that's going to set it off a little bit. I'm going to try to be easy with it right here and not, I need to hold it, but you just got to be real gentle with it and not dig in. We'll go ahead and start one just like that. Just enough to hold it, that's all. We'll come around here to the front, do the same thing. Put one in here and get that one just tight. I mean, just barely tight, really. Now I'm going to loosen it again, hold it with my hand, put the next soft jaw in, snug it up, and then do the last one the same way. Trying to keep any scratches off there from the jaws of the chuck. All right, go ahead and snug them down, get a little tension on them, and then what we want to do is get a soft blow. I think I got my lead right down here. Take our lead and just you just want to seat it. You can hear it. You can hear that it's solid. If you hit it too hard and you keep hitting it, it's actually going to bounce and push back and be off of the face. So now we'll just set up our dial indicator and get it running true. This end's got a hole drilled in it, but I need to go a little bit further, because what I'm going to do is just go ahead and I'm going to drill it a little small. We got an 1.5 inch hole to put in here, but I'm going to go ahead and get it drilled, say 1 7/16, and I'll just part this piece off right here. We'll have a another piece of material to put on the rack, but I need to go a little further in there with this drill. They probably got a tapped hole in there. That's how I used to always make my gearbox shaft, so that you could put an eye bolt in it and pick it up. All right, that's probably deep enough for there. So I'll get a taper shank drill and we'll finish it out. Got our 1 7/16 taper shank drill. Like I said, we're gonna end up boring it to 1.5 inches. I'm gonna put just a little cutting oil up in there. Hopefully this drill will cut. It looked like it had a good edge. Don't worry about that smoke. A fume extractor will take care of that in no time. All right, there's the bottom. I'm gonna have to go in there and drill it again because I don't have it to the depth, just enough to get this stub end off here. That's all I was looking for. Let's see. Yeah, looks like we got just enough to go in there and part that guy off. We got a 1-inch catch rod in there. I'm using my 20N drill chuck to catch this and hold that bar. I'm also going to be using, this is my parting blade and parting holder from Pee Wee Tools. Peter sent me this. He's the owner of the company that builds these tool posts over at Pee Wee Tools. And this is the parting blade holder that he developed for his tool posts, and it works excellent in the way that they machine this so that you have a nice square clamping face pulling down on that blade right there. He supplies a blade, and it just uses your standard parting inserts right there. So I've got it set out to near the maximum opening right there, on the maximum stick out I mean, and just lined up on that shoulder, and we'll go ahead and start parting this guy off. I'm just going to part this by hand, meaning I'm not going to use power feed just because of those stringy chips like that. Sometimes you just got to manipulate the cross feed by hand so that you can get the chip the way you want it to and get it to break sometimes. Pull you back here so you can get a shot of what I'm talking about. I just like using the mist coolant when I can because it's just a cleaner operation versus all your flood coolant. Flood coolant, you ain't gonna beat it, but this is certainly much cleaner. It doesn't make such a mess everywhere. I also like feeding it by hand because you can feel it. Sometimes when you're auto feeding in an op like this, that chip will get stuck in there and start galling up on you. And that's what causes the blade to break off. I'm pretty close now. Nice looking parting job that tool did. Man, it's got that's a slick, smooth finish on there. That is nice. So that's a good little slab of tubing that I can put on the shelf now and repurpose to something else later on. All right, all we got left, well, we got to drill it, bore it, face it off the length. We're gonna make this thickness here 2 3/4. I'm just gonna get a measurement using the calipers there. So we got about 47 thousandths face off of it. We're on our last feature here. Just got to bore this to size, 1.5 inches. We've got about 50 thousandths to come out of it. Change feed direction here. This is our solid rock machine boring bar that Steve made for me. All right, we're at 465. So we got 35 thousandths. I'm gonna say 36 thousandths. I'll give them, it probably doesn't need to be, you know, spot on. I'm sure oversized. It's just, I think it's just to line something up is all. So we'll make sure that we have it 1 or 2 over. Yeah. That should have been our final cut there. I was shooting for 1 to 2 thousandths over, 1.5 inches there. And this shouldn't be a critical hole size, honestly. I think it's just a pilot for something to line up inside. Let's see where we hit our mark at. Yep, 1.502. So we are good. All we got to do now is just, let's put a chamfer here and here, and this part will be done. So our part is now complete. This is all finished up and it is ready to send out there to Andrew Alexander out in Dallas, Texas. So I did ask him to tell me what this part was because I wasn't quite sure what it was. And so he told me that this is an adjustable bump stop that holds the rubber cushion on a 200-pound Bradley cushioned Helve power hammer. I don't know exactly what that is because I'm not into power hammers. I know what power hammers do and what they're used for, but I don't know all the specific components of a power hammer because I've never really been around them much. But I believe this was a part, he was either missing this part or needed to replace it. I think he was missing it because he said that he needed this to finish up the repairs on that Bradley power hammer so that he could get it sold to the, he's got somebody that's buying it and he wanted to get it finished up. And this was the part that he needed right there. So I'm sure he'll be sharing a picture of this on the power hammer over on his Instagram page, Blacksmith Tools. He is not on YouTube, but he's very active on Instagram and shares a lot of his finds. You know, he's big into collecting and buying old vintage machine tools, buys them and then repairs them, some of them, and then sells them, including blacksmith tools such as anvils and swage blocks, power hammer, you know, all the tools for blacksmiths. He's into all the old vintage tools and all the things the heritage tools that help build this country and the world to where we're at now. He really enjoys sharing all the heritage there of the old equipment and tools that we all love. So that's it. We're going to finish this up. I'm going to get this oiled down and boxed up and get it sent out to Andrew, and hopefully you enjoyed this project. And come on back. I got plenty more to get done around here.
Hey Adam, thanks for making this part for me. It's absolutely perfect. This is the hammer that it goes on. It's a 200-pound Bradley, and it actually goes right inside this housing. So I got to disassemble this stuff. But essentially the way it works is this hole that you've put on the bottom is an adjustment for this bolt that goes through there. And what happens is there's another rubber cushion inside this right here. This bolt pushes this piece up and down to adjust the amount of pressure that's put on that cushion Helve. This arm goes like this, boom, 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 and hammers out front. So this goes in there, the rubber goes on top of this, and the adjustment is right here. Super cool. I'm gonna have to take apart the whole thing, which I will do later today. Okay, here's a perspective from the front side of the hammer. There's one of these pieces that you made also goes right there, or it goes like this, sorry, it's upside down. All right, there's one in that side already. The one you made is for the rear. So what happens is as the motor spins, this pulley spins, flywheel spins, and the eccentric is going round and round, and it's making this helve go boom, 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 boom. So this piece is like the tensioner on these rubber cushions. I can't wait to get this going, and this was the missing piece. Thanks, dude.